In this video, we'll explore how to find the equation of a tangent line using the derivative. First, let's get a reminder of how to find the equation of a line using point-slope form. If we have a line that has slope m and it goes through the point x1, y1, we'll highlight these, and then we can write it in point-slope form as shown below. So we'll just plug in our slope here, and we'll plug in our x1 here, the x-coordinate of our point, and we'll plug in the y-coordinate of our point there. All right, example 1. So let's let f of x be this parabola pictured below, negative x squared plus x plus 2. Let's find the equation of the tangent line to this function f of x at x equals 0, and then let's also draw this tangent line on the graph. So to get started, we need the equation of a line. So let's remind ourselves, if we need a line in point-slope form, we need a point and we need a slope. Let's start with the point. We know that we care about this function at x equals 0. So when x is 0, we can think we need f of 0 to get to the rest of the point. So if we plug in a 0 to our function, we get 0 plus 0 plus 2, so 2. So a point on this line will be the point 0, 2. Then to find our slope, we want to look at the derivative. So the slope comes from f prime of x. So how do we find that slope? Let's find our derivative. So f prime of x, I'm just going to go back to my original f of x and take its derivative. That'll be negative 2x plus 1. So that one was a polynomial, not too bad. I just used the power rule to find that derivative. But in particular, I need the slope at the point 0, 2. So I'll find f prime of 0. So that is 0 plus 1. Oh, not 0. So that's 1. So my slope is m equals 1. So now I want to get the equation of that line. The equation of that line, remember, we're going to use point-slope form. So we have y minus something equals m times x minus something, and we'll plug in. So our point goes here, 0, 2, and our slope goes in for the m right there. So we could leave it like that if we wanted to. That's point-slope form. I can also rewrite it. So this is what y minus 2 equals. That right side's just going to simplify to x. So y equals x plus 2. Both of those are all okay equations of the line. So let's go over here and graph it. Let's see, my point was 0, 2. So I want the equation of the line, the tangent line that goes through that point. So remember, it has slope 1. So I can then kind of go, back 1 and over 1, kind of there's my, and then up 1 and over 1. I have some points I can kind of use as guidelines. There we go. There is a sketch of my tangent line. All right, let's do another example. All right, so this time we have a cubic. We want the equation of the line tangent to the graph at x equals 2. So x equals 2 looks to be about right here, about that point. So I want the slope of the tangent line through that point I've just graphed. So again, if we need a line, we need a point and a slope. Our point is going to be 2 comma something. I need to figure out what that something is. I can do that by plugging it in. So I need to find f of 2. So that's 2 cubed minus 3 times 2 squared minus 2 plus 3. I'm just plugging into my original. That ends up being a negative 3. So 2 comma negative 3 is my point. So to find my slope, I need f prime of x. I've just got a cubic here, a polynomial, shouldn't be too bad. I'll use that power rule. So I'll get 3x squared minus 6x minus 1. In particular, I need the slope at that point 2. So at 2, I'll have 3 times 2 squared minus 6 times 2 minus 1. And if I do that arithmetic real quick, I end up with a negative 1. So my slope is negative 1. All right, so now to find that equation of the line, y minus y1 equals m times x minus x1. I need to plug these things in. So if I plug in my point, my x coordinate goes here, my y coordinate goes here, and my slope goes here. Let's write this equation a little bit better. Y plus 3 equals -1 times x minus 2. And that's a fine answer. If you do want to rewrite it into slope-intercept, that's okay as well. But let's plot this line now. I see my slope is -1, so I'm going to use that to help me graph this. So if I have a slope of -1, let's see, I'll have another point about right there, and then right here. So let's sketch that line, and there we go. Let's move it just a little bit. It looks not quite on there. There we go. All right, so there is a sketch of our tangent line. All right, let's look at one more example here. F of x is 3x squared over x squared plus 1. Slightly more complicated function this time. We'll need a quotient rule, but that's okay. We can handle that. So we want the equation of the line tangent to our function at x equals -1. So at -1, this we're looking about right here on our graph. And we want the slope of the line that goes through that point tangent to the graph. So again, to get the equation of a line, we need a point and we need a slope. Our point is going to be -1 comma something, but I've got to plug it in to see what it is. So I'll find f, not f prime, f of -1. So that's 3 times -1 squared over -1 squared plus 1. So that's 3 over 2. So it looks like my point is -1 3/2. And that checks. If you look at the graph, it looks to be at about 3/2 as a y value. All right, now we need our slope. So to find our slope, we need our derivative f prime of x. And to find our derivative, we will need the quotient rule. So we have the bottom times the derivative of the top. The derivative of the top is a 6x minus the top, so 3x squared, times the derivative of the bottom, which is 2x. And that's all over the denominator squared. Okay, and now I might want to clean this up some if I needed to use it for something else, but because I just want the derivative at a certain point, I can go ahead and plug in here if I want to. So I just need f prime of -1. So if I plug that in each piece as we go along, so -1 squared is 1, plus 1 is 2, 6 times -1 is -6, 3 times -1 squared will be 3, 2 times -1 will be -2, and this is all over. -1 squared will be a 1, plus 1 is 2 squared. So let's see, this is -12 minus -6 all over 4. That minus and negative cancels out, and we have -6 over 4, or -3/2. So it looks like my slope, m, is -3/2. So I'm ready to write the equation of this tangent line. So remember, it's y minus y1 equals m times x minus x1. So my point is -1 comma 3/2, and my slope is -3/2. And I'll just take one more step and rewrite this a little nicer. Y minus 3/2 equals -3/2 x plus 1. So there is the equation of my tangent line. And now if I want to sketch this, let's see, it has a slope of -3/2, down 3/2 and over 1. So there's my tangent line. Not quite perfect, but it's okay. We'll move it just a little. There we go. That looks better. Okay, so there is the tangent line sketched on my graph.